architecture tests. They are one of my favorite types of tests to write, and they allow you to enforce your software architecture and design rules by writing automated tests. In this video, we're going to do a side-by-side comparison of the two most popular libraries for writing architecture tests. This is what architecture tests look like, and the examples you see here are written using the NetArchTest.Rules library. This library allows you to select a set of types from a specific assembly, for example my domain assembly, and then I can write some architecture rules for these types. In this example, I'm writing a test that is going to check that the types in the domain assembly do not have a dependency on the application assembly. The hard-coded value here is actually the assembly name, and another way to get this value is by accessing the assembly instance and then getting the name of that assembly. I also have a few more tests for the other layers in my clean architecture solution, but I also have tests enforcing some design rules. Here you can see a test that is checking that the types that implement the iDomain event interface, which are my concrete domain events, should be sealed types. And this is expressed by adding the appropriate condition that the specific types should be sealed classes. You can also check for naming conventions, and I have an interesting test here that is verifying that my domain entities have a private parameterless constructor, which is helpful when you are using ORMs. For my application layer, I have a set of naming conventions and some design rules for the command handlers, query handlers, and the validators. As I mentioned, this is all written using the NetArchTest.Rules library, which I've already talked about a few times on this channel, but in this video I want to introduce a new library for writing architecture tests. This library is called ArchUnitNET, or ArchUnit.NET if you prefer, and this is an alternative for writing architecture tests in your .NET applications. You will see that this library is a bit more opinionated in how you should write architecture tests as opposed to the NetArchTest.Rules library, but when we do a side-by-side comparison, you will see that they are actually very similar. So I'm going to start by installing the ArchUnitNet library. Let's go ahead and look for the respective NuGet package, and I will look for ArchUnitNet. You will see that the NetArchTest.Rules library also shows up in the results, although we already have it installed. And what I'm going to add now is the ArchUnitNet XUnit library, which contains some assertions for executing XUnit tests. So let's go ahead and install it, and then I'm going to do some setup in my base test class. I'm going to create a separate class that's going to represent my ArchUnit base test. So let's call this the ArchUnit base test, and I'm going to implement the base test class so that I can access my assemblies that I already defined for the various projects in my solution. The first thing you're going to need to write ArchUnit tests is to define your architecture. So I'm going to add a field, and the type of this field is going to be an architecture. Let's also give it the appropriate name, and then the value is going to be created by instantiating an arch loader. Let me import this namespace, and then we're going to call the load assemblies method, and I'm just going to specify the domain, application, infrastructure, and the presentation assemblies because I already have access to them, and then I'm going to build my architecture. So this is going to be my entry point for checking my ArchUnit rules, and this will become very obvious when we write our first architecture tests. We also need to define a few object provider fields that are going to be used to define our individual layers. So the type is going to be an iObjectProvider, which is an interface, and then the generic argument is going to be an iType. And let's call this the domain layer. And we're going to construct this value by starting with an arch rule definition. This is a static class that is the entry point for defining architecture tests using the ArchUnit library. We're going to say that the types that reside in a specific assembly, and let's specify the domain assembly here because we have access to it, and this is going to give us back an iObjectProvider. Additionally, I can decorate this with a description, and let's say I call this the domain layer. And I'm going to repeat this for the other layers in my architecture. So let's add the application assembly, the infrastructure assembly, and the presentation assembly. And I'm also going to adjust my descriptions and my field names. So this is going to become infrastructure, and the only one that is now missing is the application layer. So let me add this. So this completes our ArchUnit based test setup. I'm going to move it into its own file, and then let's try to write our first architecture test. Let's, for example, start from the domain layer because we have some simple rules here. What I'm going to do is to create a copy of my domain test class, and I'm going to call this the ArchUnit domain tests. We're also going to inherit from the ArchUnit base test, and let me adjust the file name because I like to keep things consistent. The reason I did this is because I want to rewrite the existing tests using the ArchUnit library so that we can compare if writing the tests is different, and I'm also going to leave the base implementation in place so that we can execute both of them and then verify that they behave in the same way. So let's start with our first architecture test that says that the domain events should be sealed types. With NetArchTest.Rules, this is how we would write it, and I'm going to write the ArchUnit version above just so that we can compare to the existing implementation, but later I'm going to be replacing the ArchUnit implementations. So let's start with an arch rule definition, and from this static class you have a chance to load types, attributes, classes, field members, interfaces, and once you have these selected, you can write your rules. So let's look for classes, and then I'm going to say we want classes that implement a specific interface. Now I can specify my iDomain event interface, so you can see that the design is pretty similar, and now I can write my rule. So I'm going to say should be sealed. You can see that the syntax between these two libraries is very similar and the differences are barely visible, and at this point with NetArchTest we're going to call the getResult method and get back a test result instance. With ArchUnit we can call the check method because we are already working with a finished rule, and on how you check your architecture tests is by passing in the architecture instance that you defined in your base class for your architecture tests. So let's get rid of this old implementation, and then this is what we are left with. Let me run my new architecture test so that we can compare it with the behavior of the test that we already know is working. So I'm going to execute our tests, and these are the architecture tests for the domain layer, and you can see that our new ArchUnit test is passing. To show you that this actually works, I'm going to find an implementation of the iDomain event type and then remove the sealed keyword. And now let's rerun our tests, and I'm expecting 2 tests to fail, and you will see that this is indeed the case because both the NetArchTest version and the ArchUnit version are working as expected. If I go ahead and revert this and bring back the sealed keyword and now rerun my architecture tests, you will see that all of the tests are going to be green. So this proves that both libraries function in the same way. And now let's rewrite the other tests that I have here. The next test is somewhat similar, only this time I'm enforcing a naming convention for my domain events. So instead of saying be sealed, here I'm going to write have a name ending with domain event. And you can see that it's very similar to the original NetArchTest implementation. The next test that I have is going to be a bit tricky because of the way of how ArchUnit works, but nonetheless, let's start with an arch rule definition. Then I'm going to select classes that can be assigned to my entity base class. So I'm going to say type of entity, and then you can call the getObjects method and pass in your architecture to get back a list of types. This doesn't return the .NET type, but rather it returns a class which is specific to ArchUnit, which also means I have to update the remainder of my test. So now I'm working with a class instead of a type. So how do I get the list of constructors and check if there is a private constructor without parameters? Turns out this is not too difficult. I can call the getConstructors method from ArchUnit, and now this returns a collection of method members. To check if our constructor is private, I'm going to access the visibility property and then look for types where the visibility is private. And then for the parameters, there is a parameters property. And all I need to do is say that the parameters any returns false. And this gives me my failing type. Only I should replace this with a class from ArchUnit. And this is what our test would look like. Now to actually break this, let's, for example, go to the activity entity, and I'm going to remove the parameterless constructor. And now if I rerun my architecture test for the domain layer, you will see that the 2 test cases are failing. Both are checking if there is a respective private parameterless constructor on the entity type. So if I revert this change and rerun my tests, you will see that the NetArchTest and the ArchUnit versions are both passing. As you can see, it's fairly straightforward to go from one of these implementations into the other. Now let's try to rewrite our application tests. I'm going to make a copy of the application test class and let's rename it to ArchUnit application tests. I'm also going to inherit from the ArchUnit base test, and then let's rewrite this to work with ArchUnit. So we have to start with an arc rule definition, and then I'm going to look for classes that implement these specific interfaces, and I'm rewriting the existing implementation on purpose so that you can see how similar these two libraries actually are. Now to just run my test, I'm going to call the check method and pass in the architecture. Let's do the second example. Again, I'm going to start with an arc rule definition, and then let's look for classes that implement the iCommand handler interfaces, and we are checking that these classes should not be public. All I need to do now is just check my rule by calling the check method and passing in the architecture. Now I'm going to quickly rewrite the remaining tests here. So let's replace this with arc rule definition classes, and then let's just check this rule. Then the next test case here, let's call the check method and pass in the architecture. We'll do the same here, and you will notice that we don't have the inherit method with ArchUnit. So what you can do is replace this with r_assignable_to and then the same type, and then you can check your architecture rule. And let's reuse this for the last test case, only I'm checking that these types should not be public. If I go ahead and run my application tests that are now implemented both using NetArchTest and ArchUnit, you will see that they are all passing. To show you that this actually works, let's find some validator and let's make this public. And now I'm going to rerun the test quickly, and you will see that the two tests checking that our validators are not public types are failing, and if I fix the failing type, all of the tests are now green. And lastly, let's go ahead and rewrite our layer tests using ArchUnit. So let me rename this to ArchUnit layer tests, and let's implement the correct base class. I'm going to expedite the rule definition here to show you how we would write this using ArchUnit. We start with an arc rule definition, select the types, and then we want to say which layer they belong to. So we are using the iObject provider that we defined in our base test class. So this represents our layer definitions, and then we're going to use them to enforce our layer references. So in this case, the domain layer should not depend on the application layer or the infrastructure layer. In the same way, the application layer should not depend on the infrastructure layer, and it should also not depend on the presentation layer. And I have one more rule here, that the infrastructure layer should not depend on the presentation layer, and you can see the ArchUnit rule definition and the NetArchTest rule definition side by side that both enforce the same rule. So let's run our ArchUnit tests side by side together with our NetArch rule tests. I'm actually going to rerun the entire architecture test suite, and you can see that all of our tests are passing. So which of these do you find simpler? Is it the ArchUnit version or the NetArchTest.Rules version? In my opinion, they are both almost identical, and it's not really going to matter which one of these you choose to write your architecture tests. If we wanted to compare them in some way, we can look at the number of downloads from NuGet, and you can see that the NetArchTest.Rules library has about 2 million downloads, while the ArchUnit base library has about 1.6 million downloads. However, if you factor in the XUnit, NUnit, and the MS-Test versions, it does come out on top in terms of the number of downloads. I'm not biased towards any of these two libraries specifically, but if I had to choose, NetArchTest.Rules has a slightly simpler API to work with. One more thing we could judge them on is when they were last updated, and you can see that NetArchTest.Rules was last updated in 2021, while the ArchUnit library was updated more recently in 2023. So this could be another way to compare them. While we are still on the topic of software architecture, modular monoliths are currently trending, and if you want to learn more about this software architecture, then you should watch this video next. Thanks for watching, and until next time, stay awesome.